right. Okay, good. Good afternoon, everybody. My name's Dean Croak, Chief Analytics Officer at FreightWaves. We've got a session this afternoon, Commercial Telematics, Reshaping the Future of Transportation. What I'd like to do is just give you a little bit of an idea of how we're going to do the session today. We've got each of the panelists are going to give us a short sort of overview of their view of the world as it relates to the subject, and then we're going to go to some pre-planned questions that we've got to sort of talk a little bit more in depth about some aspects of it, and then we'll go to Q&A at the end of the session. We'll have about 15 minutes left to handle that part. So let me introduce the panelists. On my immediate right, Jason Penkethman, or JP as he's affectionately known. JP was my boss for the last year, so he ranks very highly on my list of some of the best bosses I've ever had. But JP comes from the telematics background. He's worked at some pretty big firms like Nokia, Motorola. He's got 25 years of global experience in software technology, connected vehicles and IoT. He's Chief Product Officer at Spirion, based out of Irvine, California. Bill Kozek began his career as an accountant at Peterbilt in 1987. Bill has worked in a number of different roles at PACCAR, including Vice President and President of PACCAR in China. Bill is President of North America Trucks and Parts at Navistar. And on my far right, Sandeep Kaur from Fleet Complete. Sandeep is the Chief Strategy Officer. He leads corporate strategy at Fleet Complete with a mission to develop a leading global provider of IoT solutions. Sandeep, I don't know if you know, his prior role is quite famous. He worked at Frost & Sullivan and produced a lot of thoughtful reports, thought leadership type reports at Frost & Sullivan. So with that said, we'll get started, and I'll take a seat and we'll ask some questions as soon as each of the panelists go through their session. So JP, I'll hand it over to you to give us your view of the world.
All right, well, thanks, Dean. It's great to be here and also to be on stage with a fellow Australian as well. I think, you know, we can take over this place.
We could.
In a few years. So, yes, as Dean said, I work for Spirion, and we're focused on connected vehicle technology, and that is in the automotive space as well as the commercial fleet space. And, you know, working in telematics for several years, obviously there's been a lot of adoption by fleets over the last several years, and solving a lot of problems, driver safety, fleet efficiency, and maintenance of assets out in the field. And a lot of the companies that, of course, that we're serving are seeing those benefits and the ROI. What's really exciting for me, and when I think about the future of transportation, is that the maturity of the telematics industry is happening at the same time that we're seeing these other technologies revolutionizing our industry in terms of just IoT in general, but also machine learning. Even though machine learning has been around for, well, since the 1950s, it's really been only recently that we've been able to do deep learning and have massive data sets to be able to work from. So applying that to telematics is a huge benefit. And of course, everything you heard this morning around blockchain, of course, is another interesting area that we can apply telematics. So I think it's a very interesting time to be working on telematics because of these converging technologies that can really accelerate the adoption and transformation of the enterprise.
Mm-hmm. Okay. Bill?
Thanks, Dean. And you know, a number of my comments really echo Jason's comments. It really is all about, you know, its maintenance, its safety, its efficiency. For us, we really started this journey a few years back, and at the time we were going through some tough issues, and one of the decisions we made was that we weren't going to be a proprietary system. We looked at all the telematics providers out there as partners, which really helped us develop the system that we have today. And if you ask me, okay, ultimately what's one goal, besides obviously safety is always first and foremost in all the things we do, what's the one goal? And that's really to develop a vehicle that has zero unscheduled downtime. That ultimately is the goal. We believe we can get there. You know, I think if you saw our presentation yesterday, we mentioned 30% of the vehicles in the service bays at international dealers don't need to be there. So if we can prevent that, this industry-wide technician shortage could be alleviated, and there's some things we can do and spend our resources in a much better way. So telematics I see as the gateway. We're really at the, the cutting edge. This is only a couple, 3 years old for us, but we're really at the gateway of what's going to develop, and it's going to open up a number of avenues for us, including autonomous and safety systems and all the systems that we've been talking about for the last 2 days. So it is an exciting time. There's still a lot of learning. There's still a lot of testing to be done, but it will be, this is certainly a when, not if situation.
Thank you, Bill. Sandeep?
Thanks. So in my role, I head corporate strategy at Fleet Complete, so I typically look at 5, 10, 15 years out and try and understand the opportunities for our organization. We pride ourselves in helping fleets not only save money but also make money. So that is in relation to a change that we have been noticing over the past few years. See, for the past 100, 150 years in the commercial vehicle industry, the equation was, here's a truck I've bought, what can I do with it? Right? I've purchased this truck, and am I going to haul freight? Am I going to, satisfy a given vocation? It has come to a stage now, since the past 4 or 5 years, where the question now is, here are the services a truck needs to provide. What can it do for me? And that changes pretty much everything we know about the commercial vehicle industry. And now we are seeing the relationship with the customer does not end if you're an OEM. It doesn't end when the truck is sold. It begins at that point. And then there are several different services and solutions that the truck needs to then provide. And that is the kind of large, bigger picture landscape we find ourselves operating in. So Bill talked about downtime reduction, absolutely most crucial. A lot of surveys have been done that show that downtime is a fleet's biggest enemy. So anything that we can do to reduce downtime, whether it's to prognostics or remote diagnostics or whatever comes next, those are some of the focal points. The idea in our industry right now is who offers the most comprehensive solution. And the answer to that is nobody alone can do it. Whether a TSP, whether an OEM or anybody else, we need strong collaborations and partnerships. So today I hope to discuss some of those and explore how we can deepen some of these relationships and partnerships moving forward. Thank you.
Thanks, Sandeep. So in terms of our session today, there's 3 themes we're going to pursue. One is freight visibility and how telematics plays a role. The other is vehicle diagnostics, and the last one is driver safety. So what I'm going to do is work through some pre-prepared questions on each of those topics and ask each of the presenters to speak to that. So on the subject of freight visibility, freight operators in sort of the trucking space rely on multiple partners and vendors to manage their fleet. So JP, what do you think needs to take place in the industry so that all of the different players in the supply chain can aggregate all of this data into a way that's accessible but still protects companies' proprietary data sets?
Well, okay, so I think the visibility is a challenging one because a lot of companies, including my own, have a different role to play in the value of the services that we're providing. And so I think there's a level of cooperation required between suppliers and companies in the value chain. And so, wherever you have your focus and your strengths, then you open up that data and and share it essentially. And so I think that creating the ability to share that data or is obviously what we need. It's a challenging thing to do because sometimes we're competing.
Right.
And so I think there's a level of co-opetition needed, right? And so standards, I think, are the ultimate goal, to have standards in the way that we do that. But in the meantime, companies just need to play together well to be thinking about the customer's needs. And I really think that this is very much driven by the customer. So the fleet companies that we deal with, they're the ones that are really going to make the decisions on who they want to provide the services for them and where they want their data from and who's going to manage it. As much as different companies would like to dictate that, I think that customers will make that decision themselves based on the ROI, because a lot of solutions maybe have some overlap.
Right.
And so I think that that's a big part of it, is that we're just going to have to make sure that we play well together to support the end customer's goals.
Right. Yeah, one of the use cases we were working on last week with one of our blockchain partners was the certification of tyres on heavy vehicles based on tyre wall performance. And of course that's very proprietary to a lot of the tyre manufacturers, but we needed the tyre wall performance data to validate that this particular vehicle could go on these roads with the right number of trailers and had the right roll stability control, rear bit amplification, centre of gravity. There were a range of things that we had to meet to prove that this vehicle was worthy of where it should be, but the tyre manufacturers wouldn't share their IP around how their tyres were made. So we ended up with a kind of a roadblock, literally.
Yeah. I think just to add one more point is that you also have this dilemma: who owns the data?
Right.
Okay. Whose data is it, and who has the proprietary information? And so often when we're creating partnerships, we need to make that determination. And there's the raw data itself, and then there's the data that is formed as a result of it, the derivative works.
Yep.
And so often there's discussions, with the different companies that we're working with on who has the rights to what and how is that shared.
Yep.
And I think if you're focusing on the end customer and the fleet, you want to solve their problem first. Share the data to solve the problem. It doesn't mean you're going to go necessarily create derivative works and go resell that. It's you want to solve the customer problem. So share the data that you can to help us solve the problem for the customer, and you can retain the rights, but we need to provide the service.
Got it. Bill, you're uniquely positioned given your somewhat agnostic approach to the market with On-Command.
Right.
So what's your thoughts on...
Well, I mean, the first thing, Jason, I need to respond. Do you really think we're going to play nice together? I mean, come on. I'm joking, but that really does have to happen. There's got to be either that, or you've got to get standards, and you've got to choose, VHS or Betamax. Which direction are we going? So that's one piece of this thing. But it is going to take, and we have the same. It's not a debate so much about who owns the data. We believe that the fleet owns the data. Now, we may or may not be wrong, and we could probably discuss that for a long time, but ultimately, we want to use that data, though, to improve not only that fleet's vehicles, but everybody's vehicles, because that data is extremely important as we move forward. So the proprietary nature of the systems means we've got to work together. Otherwise this thing doesn't work. And our competitors have gone down a proprietary road that, I'm not sure that long term that can be done, because our customers don't all buy one model of truck, and they don't have the same telematics provider. So it is going to be a situation where collaboration is key.
Got it. Sandy?
I'm going to urge you to look at it from a different angle. I mean, the same data, let's consider transmission data. From a prognostics perspective, that data is valuable to a fleet because it can help reduce downtime. That data is valuable to an OEM because it can help in better warranty administration. That data is valuable to a transmission supplier because he or she can monetize it different. When that data is valuable to us in the telematics community because we can create solutions around it or monetize it in different ways. So, in terms of who owns the data, obviously it's the fleet's data because they are the ones who own that vehicle at that point of time when the data was emanating from that vehicle. But that said, who benefits from it? Just about everybody. So the debate, I believe, should be around, if everybody benefits from this data, then what's the point of creating walls around the data, just like Bill mentioned, right? We need to break down some of these walls because it's in the benefit for the entire society. And that smart transmission can tomorrow help save a life, can help reduce congestion, can help create new revenue streams for the aftermarket. There's so many different implications of that. So, a bit of, I would say, different thinking along how the data can be leveraged in a way that it benefits all, so that everybody's a stakeholder in this, rather than keeping certain people out of it, is the right approach, I believe.
So it's interesting, one of our other blockchain partners, one of our other bidder members is working on a blockchain solution for mileage-based leasing costs, which is a really interesting concept. So instead of periodic time-based leasing, they're working on ways to weight miles. Because as you know, when you get all the telematics, when you get the sensor data off a transmission, for example, you know what sort of load the vehicle, the stress the vehicle's under. And the theory is that not all miles are the same. So if we could find a way to use telematics data to weight the miles that a vehicle does based on how hard or easy the miles are, maybe we could make a leap to what the real value of the vehicle should be in the residual.
If I can start on that, I mean, think of miles, tracked miles, as not just in the context of diesel vehicles. Tomorrow, if let's wake up tomorrow and find every vehicle is with electric powertrain, where will all those tax revenue dollars go to that are now generated by diesel or gasoline? So what's going to come, and I think the state of Oregon is doing that already, is you track electric vehicles by miles, and then you can charge those vehicles. So that is there. There is that implication as well to think about. So yeah, so basically, the simple data of location lat long can actually create possibilities for the future mobility and smart mobility models that we are thinking about already.
Sorry.
Yeah, and the other thing is that data is valuable for us, that we can then help the customer pick the right component or the right service code, or it makes it a lot easier when the data can be used and it's simple and reliable, obviously.
Things like final drive ratio of the rear end, so based on the data coming out of the transmission, you can understand the load on the drivetrain and the related fuel economy, for example, gear selection.
Yeah, and I was talking to Max Fuller last night, and he mentioned, 5 years ago, you could get all this data in 60 days.
Right.
Now you can get this data, maybe not real time, but certainly within 10 minutes.
Right. That kind of leads us into our second theme, which is vehicle diagnostics. And one of the things that we've seen emerge in the last couple of years is the whole, you think about the telematics device on the vehicle, in particular the telematics service providers have become a gateway to get a lot of this vehicle off the device. So what's that created is this need to, understand diagnostic trouble codes, DTCs, translate them into some sort of meaning, create a triage situation where, we know a truck is going to have this problem, we're going to derate the engine if you don't do certain things, and by the way, the part that you need is at this particular location, in the next 24 hours. So it's enabled this real-time visibility into reducing downtime, hopefully preventative maintenance cost. The other is what Sandeep calls edge maintenance, which is also known as remote engine diagnostics, where you can remotely dial in and do some diagnostics on a vehicle in motion, or you can use machine learning technology to anticipate component failure. So there's sort of a number of different themes around this that the telematics device enables. So we want to go to some questions and talk about, is this whole world of remote vehicle diagnostics and preventative maintenance and predictive maintenance, is that the next frontier, and what sort of obstacles do you see?
Well, I think you're right. I think there are different degrees of complexity, and at the simplest level, maintenance can be just odometer. A lot of preventative maintenance can be resolved just by knowing the number of miles that any vehicle has driven. So the simplest form, just having that data. But then it gets to idle time. So 1 hour of idling is about the equivalent of 30 miles of driving or something. So so idle time is another factor, and then you get deeper into diagnostics, and then we get to the point of having a weighted scorecard on the diagnostics you're pulling from the vehicle, and determining which vehicles are kind of in the red zone and need to be serviced right away, and the others that could maybe wait for their preventative maintenance. And then on the edge side of doing the computing on the edge, I think we still have a ways to go. I like the concept. I just think that it's a ways out for a number of reasons. The computing power on the edge is still somewhat limited because of costs, and depending on the type of asset you're talking about, some of these are unpowered assets and maybe running off battery, like a container or something like that. These are unpowered assets, might be sitting out there for a long time, and you're not necessarily looking at diagnostics there, you're looking at other things. But depending on the type of assets and how they're powered as well. And the other issue, I think, especially for the trucks themselves, the diagnostics, is a lot of that intelligence is still in the mind of the mechanic. And it's very, very hard to do that. You can look at correlation of data for diagnostic trouble codes and other parameters, but it's very hard to do what a mechanic does so well, because they know that certain make and model and year and everything combination, that this DTC with this other behavior is because of this. And I think it's going to be very hard to get to the point. We're going to need a lot more data sets on diagnostics and correlating that data before we can have that machine learning to be able to do that on the edge. I think it's a little ways out.
So you've sort of triggered my thought process, because last year we worked on some trailer data, and we had trailer fleets that were doing some periodic maintenance, and their logic was we'd touch the trailer the trailers were running about 30,000 miles a year, and they would touch the trailers every 3 months. So it was a 90-day PM cycle. And the problem was that some trailers were doing 20,000 miles in that period and others were doing 5. So what you miss in that is you over-service some vehicles and you actually under-service others, which leads to CSA violations and roadside failures. So I think the telematics actually gives us a lot more intelligence into what Sandeep calls edge maintenance, which is how you sort of think more proactively about maintenance as opposed to reactive. Thoughts, Bill?
I think that's very well said. It's the proactive nature of handling an issue. If you take a look at our advanced diagnostic system, it is built around what are the codes that are going to that trip today that you can fix today that you don't have a breakdown next week. That to us is one of the keys of the entire system, because when you have that situation where you need to put a vehicle on a tow truck, it just starts to exponentially drive the frustration and cost and anger of that customer. So you really want to prevent that at all costs. The other thing you want to prevent is, hey, every time a light goes on, it goes into the shop.
Right.
That also is an issue. So if your system can let the driver know, hey, got to get this into the shop today, or, hey, you can wait or continue to drive to Billings, Montana. That is a big benefit to the end user and certainly to the shipper. Regarding, what we call over the air, we can reflash an engine over the air through our system, which we think offers an enormous amount of benefits, still in its infancy stages, but you can start to change the parameters of the vehicle to take advantage of maybe the duty cycle that you're in. It might be different in Kansas than it is in Colorado. So you could change that, certainly not while the truck's moving, but as you are, you stop for the night, potentially you can make that change. Now you might be able to get better performance into the hills of
Colorado. So you're thinking about like an over-the-air firmware upgrade based on the topography. So you might change
that's one example.
Engine specs to optimize fuel economy?
Yes.
Is that possible?
It is possible. Again, we're in the infancy stages, but we're certainly, I'm not advertising that.
Right. It'd be good if that just happened automatically on geofences.
It would be wonderful.
We hit a geofence and we change the spec of the vehicle.
Yes.
Yeah. Sandeep, thoughts?
I see it, if you ask anybody in the industry right now, what's the biggest crisis the industry is facing, they say it's driver shortage. The ticking time bomb that I see is technician shortage. Technician shortage,
right.
With the proliferation of all these distributed electronic systems in trucks are getting more and more complicated to service and maintain, and we don't have enough skilled technicians. Thankfully, we have solutions that are to the rescue, and edge maintenance that you were talking about. The concept is very simple, is that, you don't have to bring the vehicle in for a scheduled maintenance, and I know this is going to scare some of our OEM friends here, every X thousand miles or Y thousand hours, but if there is a problem that is anticipated, if there is if the prognostic system finds out that the engine is going to overheat in 500 miles and transmission is going to fail in 1,000 miles, then and only then you bring it in, and that's how you reduce overall life cycle downtime of that vehicle. Jason mentioned that technology is not there yet, but this is something that is coming. And we need to be prepared for that because it solves some of the industry's most teething problems right now, which is technician shortage. So how we achieve that as an ecosystem is the question. But as Bill mentioned, remotely sending an OTA to a truck is now a possibility. In fact, another new option now that people are talking about is can a truck get demand? Can a truck demand power on the fly? So today you're using the truck for city hauling. Tomorrow you want to use it for, let's say, climbing a hill. You get that 50 horsepower delivered to the truck remotely, and then when you need it, you use it, and then after that it's gone. So all these possibilities, the moment you connect the truck to the world outside and the world outside to a truck, you can enable all of these communications. And that is once the proliferation and usage of these technologies will increase because of market pull rather than OEM or vendor push, that's when we'll start realizing the benefits of some of the other ancillary technologies that become available then, and edge maintenance is one of them.
So we might come back to technicians a little bit later because I think it's a particular issue that's extremely challenging because there is a technician shortage and given what we're seeing with DTCs are coming off. There's a general theory with diagnostic trouble codes that it's not one DTC, it's a cluster of DCCs that actually point to a problem. But knowing how to triage that situation and interpret, it's sort of like a waterfall concept. You've got to go down through the DTCs to find the actual problem that's driving what the driver's seeing on the dash. So, all right, so let's switch gears a little bit. Let's talk a little about driver safety and how telematics is playing a role. JP, I'll go to you first. Video telematics, extremely confrontational to drivers. A lot of drivers have had a lot of angst about them. I think a lot of us have angst about anybody videoing us in a workplace. There are pros and cons. I never leave home without my dash cam now in my truck just for protection because car drivers do crazy things. But it's also a way of me being able to prove what happened. So let's talk about inwards and outwards video telematic technology and what we think the pros and cons are.
So I've worked with law enforcement as well and implementing telematics, and they use cameras extensively in the vehicle and now body-worn cameras, of course. And so I think there's some good lessons to be learned from that. There's obviously a privacy discussion there, and they have a lot of other things to consider, use of force and things like that, which we don't have to think about for fleet. But I think at that point you mentioned there about understanding what actually happens and from a legal perspective, a defensibility, a liability, especially for the forward-facing cameras, I think that's really important. Not necessarily for drivers to say you're doing the wrong thing, but to prove they were doing the right thing. And that there's a lot of complexity in accidents and things that lead up to events that often get missed from the driver's perspective, and the data from the vehicle itself may not be there, but when you see what's happening around the vehicle, then you get a whole different perspective. So I think that there is a lot of value in that. The driver-facing camera is a different situation, of course. So yeah, you could create an argument around monitoring drivers' facial expressions and are they starting to fall asleep, and are they paying attention? I think if there's proof in the data that by monitoring certain characteristics of the driver actually leads to a reduction in events, then there's a case to be made for possibly, causing a concern for privacy because of the safety risk. And I think that's really the debate is at what point and what inflection point does the safety outweigh the privacy concerns.
Got it.
I mean, I don't think anybody wants to have a video of themselves scratching their nose, when they're driving a truck, but if it helps them and stops them from falling asleep, and there's some immediate real-time feedback for them to be aware that they're nodding off, then it makes perfect sense.
What's the fear that the internet has so much bandwidth that it can run a video loop all the time of you, and it's capturing every minute. And the reality is it's only capturing little bites of information that are event-driven by acceleration or deceleration. So that trying to get people to understand that is a really big issue in overcoming the resistance. Bill?
Yeah, I think you said it very well. It's the education piece. That, most of the drivers that like it are typically the very good drivers. They like it, they want it. They're not crazy about the camera pointing at them. But we try to look at it the same way what you just mentioned. It's the proactive approach. Is his eyes starting to get drowsy? Can we send him a note that says, hey, take 15 or whatever you need to do? But that's the piece of it. The safety piece, the liability piece, those have become so enormous that you've almost got to do that. And hey, there's things at my company that I don't like, and they can follow every keystroke on my computer. So hey, it's just the world we live in. So education for the driver and for dispatch and for the owner, that really to me is the key on the video and the cameras. Yeah. Because when you see an accident from that camera and you see what the one that caused the accident ultimately claiming, you realize, hey, this is something that just has to happen for business today.
Right. Sandy?
I see video safety as a solution to the biggest crisis that I was talking about we are facing, which is driver shortage. You know, why is there a driver shortage problem in the industry? It's because we don't have enough skilled drivers. A lot of older drivers are retiring and younger drivers are not coming in. In fact, if I were to ask you the percentage of drivers that are 30 years or younger today in the driver pool, you know the answer is 6%. It's scary. Younger people are not joining in because you know, truck driving is not a very well-paying position anymore. It used to be back in the 70s, 80s. It's not anymore. So if you position this technology of video safety as one that helps incentivize drivers for safer driving, that can be monitored through video safety, you actually have a better chance of that resonating with drivers. And it doesn't have to be facing the driver. It can be facing the road ahead. And in many cases, and you know, people are out to sue and litigate truck fleets all the time, but now you have rich contextual video data that exonerates drivers, helps reduce insurance claims, at the same time helps incentivize drivers for safer driving. And in doing all of that, fosters a safe, you know, driving culture in fleets. Right. And there are solutions out there that are expensive, but let me take out my smartphone and show something that people won't realize. This is a smartphone. This can be a video safety tool too because it has two cameras, one facing outbound, one facing inside. Right. So what we are doing at Fleet Complete is we have brought out a solution that is smartphone enabled. At the same time, we also have a dedicated dash cam solution. And these are all AI-based systems, so there's no manual, you know, analysis of the data. It happens within the device, and only mission-critical data 10 seconds before and after a given infraction or incident goes out to the fleet. So there are solutions available. It's not that video data is constant monitoring of a driver or constant monitoring of the road ahead. It can be event-triggered, and it can be made possible at various price points, and that's where we are focusing right now, and we have solutions out.
Yeah, and we don't, you know, the price points continue to get better.
Yes,
I think on
indeed.
everything, you know, certainly the lane departure cameras are, I would tell you, they're in almost every vehicle today, and the prices are, you know, extremely, extremely reasonable.
I had some experience with a microsleep detector in a prior company, and the execution of it was pretty bad in that the technology was put in the trucks without really educating the drivers. And the microsleep detector was detecting a particular rate of eyelid closure when you have a microsleep. And to the camera, when the eyelids closed, the camera couldn't tell the difference between the driver's eyes were shut and when they were texting, because to the camera, the eyes looked shut. And the problem with the technology was the drivers were either you know, painting something over the lens, putting black tape over it, and some of the shifts where we would see drivers handing out black electrical tape were to cover up the cameras. And it wasn't they were worried about falling asleep because they had no memory of the microsleeps, because you're not designed to remember sleep. It was this other behaviour they were trying to avoid. And so what the technology did, though, in the end, it actually changed behaviour. And how we did that was we had to educate drivers on the physiology of why they would fall asleep at the wheel, so they realised the technology was a friend, not a foe, because they believed it was a gross intrusion in their workplace. What they didn't realise when we showed them the QuickTime video files of them being asleep for 5 seconds, their typical response is, "That's not me, that didn't happen." And then eventually you go, it happens enough, they say, "I've got serious problems at home, I'm not sleeping." And you find this cascading list of, you know, things that are going wrong that are leading into the workplace. Fast forward, what it does, the technology actually changes behaviour. It actually influences how people think about coming to work. That's the fundamental difference. But the key is you've got to educate the drivers on why the technology is a benefit to them.
So you're saying we need cameras at home to make sure they're not having problems at home they bring to work?
So, you know, the easy solution, just teach them how to sleep. So that's a whole other workshop for another day. But that is all you need to do. If people know how to sleep, then they'll come to work well rested.
But there's another thing about video data that we need to also understand in the context of autonomous mobility. Once you start capturing this video data, and if you're working with the OEMs and others, then this becomes fundamental input for creating better autonomous models. Right. Because video data is the richest kind of data that you can get. It's visual, it's contextual. Right. It helps bring even better autonomous driving solutions to the market.
Right. Okay. All right. Any other thoughts on video safety? All right. Okay. So let's go back to freight visibility. One of the things with freight visibility and the whole, connectivity, IoT, smartphones, supply chain, is how real time is real time. Like, so what's really required? A lot of telematics devices are pumping off data in maybe every 15 minutes. It's capturing it 1 second increments and then feeding it up to the cloud. Some companies are working on real time, like every second, like sort of high frequency data ingestion. So what do you think we really need? Like for freight visibility in the supply chain, how real time do we really need data?
Well, I think it depends on the type of freight that you're carrying and the type of asset that's delivering that freight. So for a container that's traveling on the ocean or on a train line, maybe you don't need every second, right?
It's mode specific.
Exactly, and then it's unpowered, and so having a battery that's supposed to last several years is not going to survive transmitting data every 30 seconds, and maybe that's not relevant. So I think it needs to be, applied to the correct use case.
Right.
But we live in an economy now that I want everything now, and I want to know where everything is now, and that's, we can thank Amazon Prime for that. And Uber, I want to know exactly when that vehicle is going to arrive to pick me up. Right. And so I think that the same is happening in the freight industry, that we do want to provide more granular data, because there's a lot of good information in that data as well. It's not just about, where is it, but a lot of things can happen on a journey, on a trip. And if we're looking every 2 minutes, a lot can happen, a lot can change in 2 minutes. From a safety perspective, from a security perspective. So we have a lot of customers that do cross-border transport, and they would like much more granular data when they're going across the border.
Right.
So I think that it really is use case dependent, but there are dependencies on the power that can be provided, because you need to support the transmission of data at a high rate. That takes power. And then there's the cost too, right? There's the additional cost of cellular data costs, even though they're going down with CAT-M and narrowband, that will help. But still, there's the ingestion into your platform, and then there's the storage, and then there's the transfer of that data to wherever. You pay every time you move data. And so I think if you're moving large amounts of it, you have to be also thinking about, why is it you're moving that data? What's the problem you're trying to solve?
Right. Because in some use cases you've got like usage-based insurance, where they want to know sub-second deceleration values, and sub-second capture of data is enormously, consuming, both in terms of...
And so in that case, use a circular buffer and you dump the data out unless there's an event, and then you transfer the data and you get very granular data from the time period leading up to it.
So Bill, how real time?
I think it's the difference between need and want. I think, what do you need? It's really, that should be decided by a cost-benefit analysis of, all the reasons that Jason just mentioned and the cost associated. I'll tell you though, but the want is, we want it immediately. I didn't know that I had a problem when I ordered a pizza of knowing where it was, but once I discovered that I could tell where it was in the process of delivery of a pizza to my home, I spent the next 25 minutes watching the pizza move along the path, which I got to tell you, it just killed that 25 minutes, but the kids loved it. They went crazy. So it's a now world. We want to know where it is at all times, and we got to figure out, okay, where's the cost benefit of that?
Right, good point.
You know what drives it, all of this? In 2005, about $20 trillion worth of retail transactions happened globally, of which only 0.5 trillion was on e-commerce platform. By 2025, that's going to reach 20%, which is about $4.5 trillion worth of e-commerce transactions will happen. And the moment you conduct an e-commerce transaction, automatically the expectation is you now need visibility into that freight. My daughter is 10 years old. She expects when dad buys something from Amazon, it should reach our doorstep next day. My son is 2. By the time he'll be 10, he will expect it to reach us next hour. What's going to bring that stuff to our doorstep is going to be a truck. I mean, some people say drones. Drones can't lift heavy stuff yet. So it's going to be a truck. And visibility into that location of that truck is going to be far more important than ever before. So, and real-time visibility. Now, once that is guaranteed, what we do with that data as a TSP, what we can do with the data is fascinating stuff, because location data is not just location data. So aggregation of location data gives us unique insights into, mobility, flow of mobility and flow of freight and all those other parameters, which helps us work with smart cities in designing better systems. So, I mean, the point I'm trying to make here is, once again, there is market pull for certain services and solutions that is dictating the need for real-time freight mobility, which will create then the need for other associated services, which will benefit all of us that, on the stage and anybody who has anything to do with the freight ecosystem.
Okay. So let's talk a little bit about, Bill, you mentioned, and I'll go to Bill on the technician shortage, because I think it's a particular problem that everybody's facing, whether you're a leased fleet or an asset-based fleet or you're a non-asset-based fleet using asset-based fleet. Finding good technicians is a huge issue, and we no longer have the guys that, like an old mechanic of mine that could diagnose a faulty injector by putting a phone up to the engine cowling. So these guys are gone from the industry, and now you've got young technicians who are computer savvy, but if I see a fault code and it says I have to do something with a particular part, how do I actually get that experience into fixing what the problem is if it's not immediately apparent?
Mm-hmm. It is that today's technician, and it's going to get even more complex as we go to, we start to introduce electric vehicles. You're going to need electrical engineers to service vehicles. Right. But, a big part of the analytics of our system is figuring out when a sensor flips a code, and, as we add more sensors, you're going to have more and more learning. This is automatically what you do. So you need to really step by step walk them through this, because, hey, today's engines are very different than they were 15 years ago. And the guy that was the best technician 15 years ago, right, he's working on 15-year-old trucks. And so it's a situation of we've got to be the ones, we as the OE, we've got to be the ones that put the roadmap in front of the technician and make it as simple as possible, because no customer today wants that truck out of service more than a day. It's very similar to how you feel about it when you take your car in the morning to get some service done at the dealership. You expect it back out the end of the day. You can't have a truck at a dealership or a shop for 4, 5, 6 days. It's just, it kills the system. Nobody has those amount of extra assets lying around to make up for that.
Yeah, unfortunately, when I get my Caterpillar engine serviced, I have to stop at Dunkin' Donuts on the way, because that's the only way I get good service. it's really hit and miss. And it's not a Caterpillar dealer, so no, it's just a... Sandeep, any thoughts on the technician aspect in your world?
Well, the technician aspect definitely is something I brought up earlier, saying that it is a ticking time bomb, and the thing that I see, the silver lining in all of this is that OEMs are working with suppliers and vendors in creating systems and subsystems and modules that are smarter, which can now communicate through the OEM's channel, a data bus, and help predict an impending failure. So if that transmission I was talking about is about to fail in 500 miles, then the service location gets an intimation that, the fleet manager gets an intimation this thing's going to happen. He tells the driver, hey, go there, go to Al's garage and get it fixed. Al gets a notification, this particular truck is coming with this particular problem, so he can source that part, have it ready, to service the truck and get it out of his store as soon as possible, and charge a premium for that and monetize that opportunity. Right. Driver is happy, the fleet manager is happy, Al is happy, and it's just a win-win-win for everybody. So yes, it's a problem, but then there are solutions available, and it's only going to get better the way I see it. Right. Sorry, I'm a glass half full kind of guy.
JP, any thoughts on the Spirion world of?
Yeah, I've worked with fleets to provide them with scorecards on the maintenance side for their vehicles, and then bridging that relationship with the service provider who's ever doing the maintenance on the vehicle, and sending that data directly to that maintenance provider, and so that the maintenance provider can proactively reach out to the customer without us being involved. We just supply the data so that they can have a conversation about the state of and the health of their vehicles. Now, doing that exercise is really great, because first of all, you've got expertise within that service and maintenance department contacting the customer, explaining them in detail what's going on with the vehicles. But it takes a certain amount of time to build a trusting relationship, because if you have a service and maintenance department calling the fleet saying you've got a problem with 10 of your trucks, he's going to say, oh no, do I really have a problem, or is he just trying to get more money out of me and bring those trucks in, right? So it takes 1 or 2 engine failures or something like that to happen that they were notified about that they didn't take action on to happen before they start to build that trust relationship.
Exactly.
And like, oh, you know, I should have listened to him before.
Right.
And so then you can have that trust. And having a technician actually look at all the fault codes that we provide
Right.
can also provide a lot more context around the severity level of these issues.
Yeah.
So again, it's around sharing of data and building that trust
Right.
around that. But I think that there's a lot of opportunity there, and having the data just makes it that much easier.
We have in Boston where I live, I have a guy that does our work on our cars, and it's taken a while to find a guy who knows what he's talking about. And he's quite experienced, and he could diagnose what's wrong with a car just by you describing what the symptoms are. But he says, my biggest problem is I'm almost due to retire, and I can't find people who want to spend $50,000 on building a toolkit of wrenches and diagnostic equipment, because today it's more computer-based and less about, you know, having a massive, rolling trolley of wrenches that are used across multiple vehicles. So that's finding technicians is a big problem. What you've seen now is moving to the audience are some microphones. So what we'd like to do is maybe go to the audience for some questions to each of our panelists around any questions. Here we are on the far left. We've got a question here.
Thank you for your time. My name is Edgar. And I was wondering, this is for Sandeep, but you're welcome to chime in, the rest of you. We talked about data and the ownership of the data, the benefit of the data, the insights. My question is, do you believe that there's an arbitrage opportunity, given that the data may have different timing on acquisition?
I'm not sure I
didn't hear the
understood.
question.
Yeah, it's a little
So if you get to the data first, you can mine it, learn the insights first. But if everybody owns it, who gets to benefit from it, would there be an arbitrage opportunity there?
Was that word arbitrage?
Yeah.
Sorry, can you
I'm
repeat?
not sure I understood the question.
Yeah.
The audio of the microphone is
We're having trouble. There's a lot of
That's
echo when we
Yeah,
hear
that
it.
mic
so
is not good.
you'd have to yell into the cube.
That's better.
So you're talking about the benefits for all users, right? My question is about arbitrage. If somebody gets to it first, grabs that insight from it first, do you see an arbitrage opportunity, and what would you guys suggest to do about it?
That's an interesting question. So basically, let's understand how the data flows. The data flows from a vehicle to the world outside, and then the system that is capturing the data is embedded in the vehicle. It could be so the way the data flows is it goes. Right now, it goes to if it's an aftermarket product, it goes to the telematics service provider. In future, and already so, if it's an OEM device, then it goes to the OEM first. So, the arrangement of who will get the data first and who will work with the data together is that arrangement is decided before even the system is installed in the vehicle. So that arbitrage issue is settled way before the data starts to flow in from the vehicle. That's the way I see it.
I think it's also an opportunity for,
go ahead.
for blockchain. In certain data elements, having that single source of truth, wherever that may be, with the OEM, or if it's a, aftermarket hardware, and then using blockchain to take that initial data, and it may need refining. I was talking to Bill about that earlier. That when you first capture the data, there's typically a lot of errors with the data too, and so you have to filter that out and know that it's true, good data. But maybe that also needs to be in the blockchain, for example, and there's a record there that the data has been modified because it's been deemed as incorrect or invalid or something. But I think having a single source of truth is important.
Yeah, really. I mean, it really is a interesting question, and I've been sitting here as my colleagues were talking, trying to figure out where could there be a gain, through the arbitrage of the information, and nothing has hit me yet, but it's certainly something that we need to think about. One, to prevent, not unauthorized access, but maybe manipulation of the information. So, but It's a good question. It's obviously similar to the whole cybersecurity thing. We've got to deal with that as we move forward with the entire industry.
I can't. Any other questions? Got questions?
So, how are you thinking about, or is security a primary topic? How much time are you spending on the security of those telematics transmissions? And
We spend an enormous amount of time on security. Obviously, with the world we live in becoming more and more complex, and the bad guys getting better at being bad guys, we've got to spend a lot of time to make sure that with a connected vehicle, somebody can't get control of that vehicle and do some of the things that we see today. So believe me, it is at the top of the list of things that we look at, because we understand the importance of the security of, one, the load, but two, the life, and three, the lives that could be impacted by that.
We see the vehicle of today, for example, a 2018 model Class 8 truck, there are 18 different vulnerabilities in that vehicle. I mean, we've done our own analysis for it, right from the door lock and lock system all the way to infotainment and many other systems which could be breached. And a truck carrying, let's say, a trailer full of gasoline or a hazmat is not a truck anymore. That tractor-trailer combination becomes a weapon of mass destruction. So the idea is, how do we secure that vehicle? And so as we build our own data analytics models, I mean, that is, as Bill mentioned, it's for us too, it's one of our key priorities. So there is security of the vehicle, and then security of the data as well that is transmitted from the vehicle or into the vehicle. So anonymization of data, removing any personally identifiable data, those are like top of mind priorities for us at the moment, and that's pretty much the norm of doing business nowadays if you're in the data community.
And the other thing that I didn't mention, and our customers are asking for that. Our biggest customers want to be able to shut down a truck right now, and that, how to do that is one thing, and being being able to do that and knowing when to do that are a couple of different things. So, but believe me, we spend an enormous amount of time trying to figure out that equation.
Yeah, I think also security, think about what kind of data you're trying to secure, for what reason. Obviously PII and things like that need to be very secure, and you can think there are multi-layered security policies that are required. There's encryption of data on the device, there's encryption during transit, there's encryption of data at rest. But at some point you're decrypting the data to make some sense out of it, either to run a report or a dashboard or something, and so there's always some sort of weakness in the chain of information flow. And so I think you just need to have a multi-layered security policy to handle the different types of data that you are storing.
Right.
You don't need to encrypt everything if it's unintelligible or not useful, because there's also a cost to it as well. So I think, as we're working with our customers, it's the same discussion around, well, how much value is in that data, and what's the cost of the security, and spend your money where you need to do it.
Got it. Any other questions? Question here.
Is this on? Can you hear me? I was curious what you thought about what autonomous vehicles, if that would change the telematics space.
So the question was about autonomous vehicles.
If it will change the
commercial telematics. Got it.
Well, there still has to be a connection to the autonomous vehicle. So I don't think there's going to be. I mean, yes, it will change it, but it will become a little bit more complex. There will be more checks and balances. You will ultimately end up still using the connection to guide this autonomous vehicle in some way, shape, or form. So yes, the answer is yes, but how that looks in another 4 or 5 years, and the regulations that we're going to need to make sure that we're paying attention to and we're answering, those I really couldn't tell you what they would be, but it's going to get more complex, and the telematics will still play a role, if not a more important role.
And when it comes to autonomous vehicles, I mean, our business model at Fleet Complete is built around the premise that autonomous vehicle proliferation will happen. So let's say the autonomous vehicles are on the highways, and the driver is not driving the vehicle is being driven by itself. Then what else can the driver do really is, the driver can try and find freight along the way. Let's say the vehicle is traveling from Atlanta to Dallas, and somewhere in the middle of that journey, there's a shipper who wants to move 5 crates of some stuff, and that driver can now pick up that freight. So I see autonomous mobility and freight digitization as yin and yang, one feeding into another. If there is demand for Uber for freight kind of technologies, then the autonomous truck becomes important. And if there are autonomous trucks, then that drives that new business model. Both of which, by the way, solve the driver shortage problem, because now the driver can generate more income and more people can be interested in this vocation of trucking.
I agree completely, and I think telematics is a very important precursor to autonomous. That everything that we're doing with connected vehicles in the telematics space is going to enable the adoption of autonomous, because you're looking at how vehicles are being utilized, you're looking at routing, you're looking at safety, you're looking at efficiency, maintenance, all of these problems that we're solving with fleets today around connected vehicle technology and telematics are all going to be leveraged by autonomous. They have to, because you can't just sort of stick some machine out there and expect it to perform without having figured out first how it's going to integrate into your business. And so I see that telematics is a very, very important precursor and will help accelerate the adoption. But, there's fleets have got a lot of things to consider with autonomous. Right. It's exciting, but a lot of work.
Did you have a thought, Sandy?
Yeah, it's exciting. There is a lot of work, but and the fact is, if you take a look at the truck of the future, let's say we focus on 2025, and what will that truck look like? We start thinking about it. That truck will be a green truck. It will be green for the environment, and it will be green for business. That truck will be a safe truck. It will be safe for the person driving that vehicle, and it will be safe for the vehicles or people around that vehicle. That truck will be a connected truck, obviously, because it will be connected to the world outside and vice versa. If you add it all together, that truck is going to be a smart truck. Now, are we smart enough to embrace that future is the question.
Yeah, there's a strong case for more tightly integrated telematics when you get to autonomous, because of the human-machine interface piece. Because, what's the person doing? Are they literally watching a movie as the vehicle's in autopilot? Or if you go to an autonomous truck, do we have to have a driver in the field of view before it can go into autopilot? Because I can tell you the first thing a driver's going to do is get in the bunk and go to bed, because that to a driver is a lesser risk than sitting at the wheel trying to stay awake. So just heads up on what's going to happen there. So I can guarantee you that's what I would do, because that would be a lesser risk. So, do you need another camera inwards now that's mandated part of the regulation before you can go autonomous, that says, yes, there's a human face in the field of view. Questions? We've got 2 minutes left. Are there any other questions? If not, I want to just touch on cybersecurity a little bit more. We talked about cyber threats just briefly, but one of our blockchain members, one of our bidder members from Israel, Karamba, have a very interesting cyber threat software package that can go on an ECM of a truck. And what it can do in real time is to detect cyber threats. So, of course, one breach of a Navistar truck is potentially a breach of all in the network globally. So they have very interesting technology, and I just wondered about, in South America it's a huge problem in terms of, the bad guys pulling up alongside a truck and literally disabling the entire vehicle, all the electronics, and then they steal the load. So we don't see a lot of that here. I'm not sure we see it at all, but what's your thoughts on the potential for that to happen, and what should we be thinking about?
Well, there's certainly the potential to happen. The trucks are... They're computers, they're electric, and there's a lot of things that the bad guys know, and they're continuing to get smarter and smarter about what to do. So, our job is to stay one step ahead of the bad guys. Right. And the technology you talked about, I recently heard about it, so I don't know how it works, but that is something that we need to make sure that we're putting in every truck, especially as we go electric and autonomous and all the green things that Sandeep just talked about. But yeah, it is a very real issue, and there's that's something that we need to make sure we've got before we go fully autonomous as an industry.
Sandeep, any cyber threat thoughts?
No, I agree with what Bill said.
Okay.
Absolutely. This is as an industry and as stakeholders in progress of connected vehicle ecosystem, it's in our best interest to be a few steps ahead of the bad guys, and that's what we have to do.
Okay.
There's no other way.
JP, you've got 5 sequins to bring us
I think
home.
they covered everything. Yeah.
Covered everything? All right. Okay. Ladies and gentlemen, thank you very much for attending. We'll wrap up there. If you wouldn't mind giving our panellists a round of applause and thank them for their efforts. Thank you.